Hey, here's warm-up number 27. Let's do some factoring. Okay, we're gonna factor this completely. So first thing I'm always looking for is a common factor, but nothing goes into 310 and -8. So no common factor here. I'm gonna use a modified diamond problem then to take care of this 3. Gonna multiply that by the -8. So it kind of just disappears from the front. Got this. Okay, I'll set that up with a diamond problem. Okay, I'm looking for two numbers that add to 10, same two numbers multiply to -24. So I'm kind of thinking 1 and 24, I can't do anything with that. 2 and 12, I can do something with that. 3 and 8 is tempting, but 3 and 8 won't work to get a 10. But I can do something with a 2 and a 12. If the 2 is negative and the 12 is positive, then that's my winning combo, right? So I've got x minus 2 and x plus 12. Okay. Now that's not my final answer because I modified the problem. So now I got to modify the answer. I'm going to take the number parts and divide them by 3 because in the beginning I multiplied by 3. Okay. Then I'm going to reduce the fractions if I can. I can't reduce 2/3, so I just pull the 3 out in front of the x. And then the 2 falls to the ground. Okay, there's my first term. 12 over 3, I can simplify that. That's 4. And then there is my solution. Okay. All right, next up, I've only got 2 terms in the next 2 problems, so I'm not going to use a diamond problem, but I'm looking for a common factor. I have one here. 2 is a common factor. Okay, and then let's see, half of 54 is 27. Okay. So I'm still going to try to factor the binomial here. It's not a difference of squares, clearly, because it's added together. So looks like I got cubes here. And I do because x times x times x is x to the third. And then for 27, 3 times 3 times 3 is 27 because 9 times 3, right? So this is a sum of cubes, which is factorable. Now you need to know the little formula for it. And here's what it looks like. Okay, there's the formula. All right, here the a and the b are going to be the x and the 3. Okay, so I'm still going to have the 2. Don't forget about the 2. I've already factored that out, but that's going to be part of my final answer. My first binomial, this part, is going to be x plus 3. Okay, and then for the trinomial, I like to set it up with parentheses just to make sure I simplify it correctly. It's easy to make little mistakes, and parentheses helps a little bit, especially if one of the pieces is negative. Okay, so this should be an a in this slot, so that's the x. And then I've got a times b in the middle here, so x times 3. And last, b squared, so that should be 3 squared on this problem, okay? And then I'm going to simplify this. So still got 2 times x plus 3. And then the trinomial, x squared minus 3x in the middle, and 3 squared is 9, plus 9. Okay. Now it's tempting to try to factor this because it kind of looks like it might be factorable. But if you used sum or difference of cubes formula, you're not going to be able to factor the remaining trinomial. That's assuming that you've factored out any common factors at the beginning. So I'm not going to bother trying that because I know it's not going to be factorable any further. Okay. So next problem, it might be tempting to think, oh, this is a difference of cubes, but no, those aren't cubes because I've got a squared term here, so I'm not going to be able to multiply something by itself 3 times to get 4x squared. But I can do 2x times 2x, right? That would give me 4x squared. And 625, let's check if that is a perfect square. So I'm just going to put in the square root of 625 into my calculator, and sure enough, it's 25. So, and this is a difference, right? It's a difference of 2 perfect squares. So difference of squares. Difference of squares formula is simpler. It's this one. Okay, so this is going to factor into 2x plus 25 times 2x minus 25. And I'm kind of just scanning those binomials to make sure there's no common factors. And there's not, so I'm finished there. Okay. All right, number 4. Now I have 4 terms. So again, I'm still looking for a common factor, but I don't have one here with all 4 terms. So what I would recommend usually doing if you have 4 terms is try factoring by grouping. So I don't have a common factor for all 4, but let's try splitting it into smaller groups. Okay, so what some people will do is they'll split it into groups like this. But you don't want to do that. Don't do that, because then I'd have to distribute this negative if I wanted to write it without parentheses, and that would change the sign of the -8, okay? So don't do what I just did there. See that all the time, very common mistake. My second group is going to be -4x minus 8. I always want to add my 2 groups together. So you can see how if you just put the parentheses around -4x or around the 4x minus 8, that's not going to be the same thing, okay? So here's my 2 groups. Now I'm looking for common factors here. Oh, 9 and 18, 9 goes into both of those. Also, x squared goes into both of those. So let's factor out 9x squared out of this first group. Let's see, 9x squared times x would give me that first piece. 9x squared times 2, give me that second piece, okay? And then in the second, I could factor out a 2, but I could also factor out a 4. So factor out the greatest common factor, okay? Now, there's nothing wrong with just factoring out a 4, but if this first term is negative, factor out the negative with it. So I'm going to factor out -4 instead. Okay, and then -4 times something is that, -4 times something is that. Okay, if I factored out just +4, these 2 binomials would be different. I'd have x plus 2, and then this would be -x minus 2. So you want them to be the same. Okay, and when those are the same, then we're in business. So what I'm going to do is factor out x plus 2 out of the front half and the back half, okay? So I'm factoring that out. So another way you can think of this, make a parentheses for what the front and the back have in common, and then make another parentheses for what the leftovers are. So the parts they don't have in common, that would be the 9x squared and the -4. Okay, so in essence, what I did is I factored out x plus 2 out of the front and back, and that leaves me with that, okay? Now, it's really tempting to put a box around that and move on, but check to see if there's any more factoring you can do. Nothing I can do with x plus 2, but wait a second, 9x squared minus 4, that's a difference of squares, right? Because we've got a perfect square there and a perfect square there, so we can factor that further. Okay, and there we go. See you next time.